Welcome to qnawire.
For this question, we are trying to prepare a buffer of 3.5 pH, and we have a 0.1 molar concentration of these solutions. So the first thing is to figure out the right combination of these solutions to put together to be able to have a pH with a buffer of 3.5. Okay, the first thing you need to understand is that uh, the Anderson-Hasselbalch equation is that you need an acid and its conjugate base. Okay, so I can't just pick ACOH and have maybe uh, a sodium acetate as a conjugate base. So I have to have, for example, the acetic acid and the sodium acetate together. Uh, so based on experience, I will first start with the methanoic acid. Okay, so looking at methanoic acid, so I'm going to pick the methanoic acid to start with, and then I'll have to pick the sodium methanoate as the conjugate base. So I'm trying to make a pH 3.5, right? So say pH is 3.5, and the pKa of the methanoic acid is, of course, the Ka of methanoic acid of HCOOH Ka is 1.8 times 10 raised to the power minus 4. So the pKa of that would be 3.745. So the pKa will be 3.745 plus log of the concentration. So the concentration, we are told that it's 0.1. Okay, so that's going to be HCOO and A concentration divided by the concentration of HCOOH. Okay, so first we're gonna have log of HCOO and A divided by HCOOH will be equals to 3.5 minus 3.745. Okay, so that means the concentration of HCOOH of HCONA divided by HCOOH will be equals to the log, the antilog, of course that's going to be 10 raised to power 3.5 minus 3.745. So that will give us 0.569. So then we can say HCOO and A over HCOOH would be 0.569. So now we can make an assumption that the concentration, or we can say the volume of the one of them is x, while the other one will be 1 minus x. So we can say x over 1 minus x is 0.569. So when we figure out x, we can figure out what the other one will be. So therefore, x is going to be equals to 0.569 minus 0.569 hex. So then 1.569 hex is 0.569. Yeah, right? So therefore, hex would be equals to 0.363 liters. So what we can do is to pick 363 let's pick 0.363 liters of the HCOONA and had 1 minus 0.363 liters of the methanoic acid. So that will give us, this will give us 0.637 liters. And if you want the answer to be in milliliters, you can say this is 363 milliliters and this is 637 milliliters. So these are the combination of the HCONA and HCOO that will give us a pH which buffer equals to 3.5. Okay.